Last week we looked at NumPy and pyplot, which are very useful libraries when we are dealing with homogeneous numerical data. So basically matrices of numbers. Today we're going to look at Python for data analysis, this Pandas library, which is built on top of NumPy and matplotlib, and gives you additional functionalities for dealing with heterogeneous tables of data. So we can have tables that combine numerical data with categorical data and strings and text and things like that. We can access the tables by the names of the columns, and we can do easily do lots of processing tasks such as identifying missing values, getting summaries, computing statistics, plotting, and so on. So on this first part, I'm going to give a brief introduction on the basic classes of Pandas. So the series, which is basically a column with an index, and a data frame, which we can think of as a table with a set of columns and a shared index. In this first lecture, I'm going to give some simple examples on how to use Pandas, and the idea is not to try to memorize the details, but for you to become acquainted with what you can do easily with Pandas, and then if you need to use this library in your work, for example, if you're working with spreadsheets containing just a table on each spreadsheet, or if you're using tabular data from the internet and things like that, Pandas can be very useful for that. And if you know what you can do, then it's easy to look up the documentation and see the recipe, so you don't need to memorize the details here. And then on the second lecture, I'm going to talk about visualization methods in Pandas, because Pandas also wraps matplotlib and gives us easy access to more complex visualization techniques that we can use from Panda. So let's start with this basic object, the series. So the series class creates series objects, and this is an indexed array. It is in some ways similar to a dictionary, because you can access data by its index, and you are relating the index to the values, but you can have duplicate values in the index, and it's more flexible, because it also includes the order of the elements, so you can access the elements either by the index or by the order in the array. And you can create series objects from a series of data, for example, giving a list of values for the data and a list of values for the index. So let's consider this example. The Brix index is a measure of glucose levels or sugar levels in water or in aqueous solution, and it's often used to follow fermentation in winemaking, so to check when the sugars in the grapes are being consumed and turned into alcohol by the microorganisms. So this is an example of how we could use the data, the measured Brix index, and for example hours of fermentation, and then we would create a series where we would assign the Brix index values as the data. So this is the first list here, and then as the index, the hours of fermentation. And this would be the series that we have. So from Pandas, we import the series class. We use the series class to create a series object with our series. So the class is a factory of objects, and we create a series object with this data and this index here. Now this starts having negative signs, because this is a measure of the density of the solution, and as the sugars are turned into alcohol, the density will start decreasing, and then will have a negative Brix index, because it starts to become less dense than just water, because it's a mixture of water with alcohol. So this is the one way we can create a series objects. And now we can use broadcasting like we did with NumPy arrays. We can use indexing like with NumPy arrays, for example, for using Boolean indexing. And just like similar to what happened with NumPy, if we take a NumPy array and compare to a value, for example, let's see when the alcohol level is high and the Brix index becomes negative, we can check the series and less than 0. With NumPy, we would get an array of false and true by comparing with these values here. With Pandas series, we get a series that has as values these arrays. So these are all the comparison of all these different values and 0. But the series retains the same index. So we can see at which time the sample became negative. The Brix index became negative on our fermentation. And we can also use these series to index our series. So we can ask from the Brix series what are the entries for which the values are less than 0. So here again we have a series with the index corresponding in this case to hours of fermentation, and here the Brix index. So we can create a new series. For example, this is the series that has the stage of fermentation where alcohol starts to be in significant amounts. It's the one where the Brix index becomes negative. And now we can ask for elements, for example, in order. So this is, if you use the iloc attribute of a Pandas series, you are accessing the data not by the index but by the position in the array. So iloc 0 would be the value of the first entry, which is this -2 here. If you want to know the index at this position, you can ask index 0. So this is 250. It's the index of the first element of this series. So basically, in a series object, you have this index and the value. There is each value corresponds to some index. You can access by index. You can use Boolean indexing. You can also access the elements by their order. Now, a data frame, you can imagine it as a collection of series as columns which share the same index. So you have a table which is basically a set of columns with a shared index. This can be created using the data frame class. We can import a data frame from Pandas, and we can, one way of creating this is using a dictionary of series. For example, we create here a new series which has temperature for different times. So these are, the index is the hours of fermentation, exactly like with the Brix index, and this is the temperature measured in the fermenting medium due at this instance. Note that the index does not need to correspond to the one that we already have. So these indexes are different, but we can join the two in a single table by creating a data frame where the Brix column will have the Brix series and the temperature column will have this temp series. And now what Pandas does is join the two together with the same index and fill with this NaN, not a number, those values that are missing. For example, in the Brix series, we have a value for 20 hours of fermentation. So this, if we see here how we created, we have the Brix value of 23 at 20 hours of fermentation. But for the temperature, we don't have a measure at 20. We have at 0 and at 50. So when we join the two together, at 20 we have, at 20 and 40, we have not a number in the temperature column because there is no corresponding value to that index here. And then we have a temperature measurement at 50 hours, but we don't have a Brix index measurement at 50 hours. So if you have these different columns that share the same index, even if the values are not the same, do not correspond, you can still easily merge them together into a data frame, and the data frame will fill the gaps, marking them with missing values. So this is not a number. You can remove the not a number in different ways. So if you have a table with missing values, now depending on what you want to do, you may want, for example, to drop everything that has missing values. So if you, from your table, call the drop NA method, so drop these missing values here, this returns a copy of your table without the rows that contain one not a number or more. So it gives you a copy of the table, but only with those rows that are full, that you have complete data. Alternatively, you may want to fill in the values. For example, this fill NA will return a copy of your table by filling the missing values. If you use this method, forward fill, it copies the values forward. So this 25 gets copied in the subsequent missing values, then the 28. You can do a backward fill if you want. This does copies the 28 backwards here, or you can interpolate. So you can use this interpolate based on the index, and this does linear interpolation between the values that you have and the values that are missing to create new values inside. So this, of course, using each particular method will depend on your data and the purpose of your analysis and so on. So you need to think about which one would be more appropriate. But the idea here is to illustrate how easy it is to, depending on what you want, drop the rows that have missing values, fill them by copying values, fill them by interpolation, whatever you need, depending on the problem you're trying to solve. So another way we can create a data frame if we don't have the series objects is just create with a dictionary of lists. So once again, the keys on the dictionary are the column headers. The values here are the values for the columns. And in this case, all the arrays must have the same length so that the data frame class knows how to match them. Note that if you use series to create a data frame, you don't need them to have the same length because they have the same index, and the data frame can see which values go with each values in the different column. But if you don't have indexes in your series, so if it's just, for example, lists of values, then they need to be all the same length in order to create a table. But this is a practical method if you need to create a table cumulatively. For example, you're reading from files, you're gathering together different data. You can just create one list for each column, add everything to the corresponding lists, and then call data frame and create your data frame like this. So this is an example using stars. This is the distance from the sun in light years. This is the apparent magnitude and the spectral type. So we have here, if we have these three sets of values, we choose the names of the columns in the dictionary, and when we create a data frame, we have this table with an index created automatically. We did not specify an index. We could have specified an index too, but we did not specify it, so it was created automatically here. Lots of things that you can do now easily. For example, you can suppose that you don't want all of these columns. You can drop a column, and this will return a copy of your matrix without the column that you specify here. So dropping on axis 1, remember that axis 1 is in this direction here. So we are running through the columns and dropping the magnitude. This outputs a matrix that is the same as the original one, but without this column. We can also drop rows. For example, we can drop the row with index 2, but this time we specify axis 0, which is the direction of the rows, just like what we saw with NumPy. And now the output is a table that is the same as the original one, but it's missing row with index 2. Note that this gives us, in general, copies of the table. It never changes unless you specifically tell there to do some change this in place. It does not change the original table. It gives you it outputs a new table with this data. You can access the columns in the data frame by the name of the column. So, for example, stars distance, and this will return a series object with the values in that column. So we have the index and the corresponding values. You can also access rows using the lock attribute. So the lock attribute allows you to access rows by the index or by things like series of booleans which share the index. For example, we want the rows for which the distance is larger than 100. And these would be the rows that correspond to that condition. You can also access the rows by order instead of the index using ilock instead of lock. So there are flexible ways of accessing data, but the main idea here is that it's easy to do these kinds of things, extracting what you need. I want these columns, I want rows that match this constraint, and so on. And that is very easy to specify once you become used to how Pandas works. Okay, so let's see an example. I'm not sure how this interface is at present because I didn't check it recently, but a few years ago we could download public spending data for the Portuguese government from this website, and it could be downloaded in CSV format, or I think now it's in Excel format, but for Pandas it's the same thing. You just use a different function to read it, but it only allowed 2,000 records at a time. So for this experiment, I downloaded records starting from January 1st, 2015, and then downloaded a new file from January 20th, 2015. There is some overlap because this file ends later than January 20, but this way I get more than just 2,000 records. So this is just to illustrate how we can merge these data together using Pandas. So this is how the data looks like. We have the contract, the name of the contract, we have dates, we have the cost of the contract, so the value that is agreed, and so on. And we can load this, since this is a CSV file, we can use the read CSV function from Pandas. So since we are going to use several things from Pandas, you can either import exactly what you need if you want, but you can also import Pandas. The typical nickname is PD, like we do with NumPy, and call it NP, and then you just use whatever you want from Pandas. So if you're going to read an Excel file, you have a read Excel function. If you're going to read a CSV file, you have this read CSV function. And this interprets the CSV file and uses the header row for the names of the columns. So you get a data frame that has these names in the columns. So this is, we can check that. We can ask, we have this table, temporary table 1 from reading the first file, temporary table 2 from reading the second file. We could generalize this by creating a list of tables if we had more files, but just to keep this example simple, I'm going to use just 2. And you can check which columns you have on your data frame. So using the columns attribute, you get this index type object that lists the different tables. So there is the different columns. There is one column that did not exist here originally that Pandas created, which is this one called index, and then there are these different column names which corresponds to these that we have here. And we can now concatenate the two tables by using this function concat in Pandas. So basically what this does is organize the table so that the columns match. If some table has columns that the other does not have, then Pandas will fill the necessary rows with missing values, with not a number, and then it puts one table following the previous one. So this way, since we have the same columns, we are just adding the rows of this table to the rows of the first one and getting a new table that joins these two together. Okay, so now one thing that we need to check is, because there is some overlap here, this first file ends later than 20 of January, we have some duplicate records when we combine the two tables together. So we can check this easily by getting here the list of duplicates. So what this gives is a series that marks with true all the rows that are equal to one row, at least one row before that. So everything that is a duplication of an entry that came before is marked as true. If we call this value counts function from this series, we get a count of the different values. So it has 3,632 false and 368 true. So there are 368 rows that are marked as duplicate in this table. Or if you want, you can just count the values and then ask for the true entry here. But note that when we, from a series, count the different values, this function also returns a series that has the value and how many times it occurs. So if you just count the values and ask for a specific value that you want, you get how many times those values occur in this series. So in this case, after asking for the duplicate entries, we have 368 entries marked as duplicate with a true here. We want to throw them away, so we can just copy into our table the result of dropping duplicates from our table. So this is one way of doing this. You can also, there is usually an argument called in place that you can set to true and just do the operation in the same table, but generally it's safer to do it this way, often putting in a different variable, but if you want, you can use the same. But in any case, what we're doing here is throwing away everything that is marked as duplicate. So all those rows are eliminated. And now we now have in our table only unique rows, rows that are not duplicated. There is still one problem, because when we load each of these files, Pandas is creating an index that starts at 0. So there are entries in this file, from this file, that have the same index as entries from the first file. And we can check this when we ask for example, table, the rows with a value of 1100 in the index. And we see that there are two different contracts that have the index 1100. So this is not good, because we have repeated entries in the index, but we can call this reset index. So if we reset index, it will start at 0. And now if we ask for the 1100, the entry on the 1100 index value, we still get the old index. So when you reset index, Pandas adds a column with the old index that was discarded when it generated a new one, but now we have only this entry. So we have this contract with this value and so forth. Okay, so now we have all the indexes renumbered from 0 to 3,631, which are the number of records remaining after throwing away the duplicates. And now we can check things. For example, we can check the price of the contracts, and we notice that this is quite an inconvenient format. So whether this was deliberate or not, it's very hard to compute anything with these values because they are strings. We have a point marking the thousands. We have the euro sign there with the space and then a comma. So these are not numbers. These must be interpreted as strings by Pandas, but we can convert them easily. So let's create a function that converts this text into a number, and basically it converts the text into a text that we can interpret as a number, and then calls the float typecast to convert it into a number. So what we do is we split using the space. Remember, we have this function that can break a string on a separator and returns a list with the substrings. So we split on the space and ask only for the first element, then what this does is split this string here and get only the first element here on this side. So we can now replace the dot with an empty string so that we throw away this part here. Basically what we did was this: we split and chose the first part. Now we remove the comma, the dot, sorry, and now we replace the comma with a dot. So we replace this part here with a dot, and now this is a string that can be interpreted as a number by Python. So once we get that, we convert this into a number and return that value. So what we created here was just a simple auxiliary function that can convert one of those entries into a number. And now what we can do to convert all the columns here, we're going to put into the same column, preço contratual, the result of applying to the values in that column this function here. So if you want to apply the same function to all the values in your column or in your data frame, if you wanted to do this for the whole data frame, you can just use the apply method, and it applies the function to all those values and returns, in this case, a series with the same index and all the values transformed. So we can just put that series and replace the original column, and now we have the data in numeric format. So this is very convenient if you need to fix some things about the data or check some things or change the data, because you just write the function for a single case and then do apply, and it applies the function to the whole column or to the whole data frame or to a subset of columns, depending on what you want to do. So now you can easily get statistics here. You can have the maximum value, the mean, the median, and so forth. You can you just ask from the column what is the maximum, the mean, the median, etc. So one thing that we can find is that there are contracts that have a price of 0. When you ask for the minimum value in that column, there is a 0. So which ones have a price of 0? This is a bit suspicious, and you can do that easily. You can create this mask, which you compare the price with 0. So basically, this will give you a series that has the same index as the table, but is true for all the rows for which the price is 0, and false for all the rows for which the price is not 0. If you want to count them easily, one easy way of counting true values in a Boolean array is just adding, because when you add true values, you add 1, and when you add false values, you add 0. So this gives you an idea that you have 9 cases where the price is 0. And you can ask from your table those particular records. So this mask is a series that has an index for all the rows that you have in your table, and true or false depending on this condition. And if you do this, you are asking for the rows that correspond to a true value in this mask. So here you have the 9 entries that have a contract price of 0. So note here that we have the new index that we created with reset index, and this is the old index that we had that restarts after we change from one file to the next. But we can, if you want, you can drop this column if you don't want it. So this is just an example of how we can select data. I'm going to give just a small example here, also with the star catalog data. This is you can get this database from Astronexus, and this is a table that lists the distance to our solar system, and then declination, absolute magnitude, spectral type, relative magnitude, and so on. So we start with our own star, Sol, and then stars that are nearby, and we have here the information on those stars. And this is an example of also a data table that would not be very practical to use in NumPy, because you have a mixture of numerical data and strings, and so it's better to use Pandas for that. You can also use read CSV. And now let's suppose that we want the 5 most common spectral types. If you do value counts, you get a series with the value and how many times it occurs on your series here. So we can get the value counts from the spectral type column, and this will tell us that K0 occurs 8,500 times, G5 60,000, and so forth. And since this is sorted in decreasing order, we can just keep the first 5 entries on this count, and we have a series with the top 5 spectral types here. So this is just another example of the kind of extra information you can extract from a table easily. Just to give you one final example on this part before we go on to plotting on the second part. This is a data set from this repository for machine learning problems, but basically this tribe, Akimel are well, famous for unfortunate reasons, because probably due to dietary change. These are Native American people that used to live off river regions, and the dietary change to more agricultural practice, more cereals and so on, led to a great increase in type 2 diabetes incidence. So taking into account the size of the population, they have among the highest incidence of type 2 diabetes in the world. So this is a sample of 760 women aged 21 and up, and has these features: the number of times pregnant, the plasma glucose concentration, blood pressure, and so on. And we have this file format, the CSV, with these data, but it's just a set of numbers. So unlike the other examples, we only have the numbers, but if we want to use this as a table with column headers and such to be more practical, we can still use Pandas, but we have to add our own column names. So this is easy to do. We create a list with the column names. We are going to use these codes for number of pregnancies, plasma glucose concentration, age, diabetes. This is 0 or 1 depending on the diagnosis. And now we can read the CSV file and use this list as the names for the columns. So if we want to get an overview of the data that we have, we can use this describe method, and we get the count, how many values we have, the mean, the standard deviation, the minimum, the quantiles here, and the maximum value, and so on. So this is a practical way of taking a look at the data just at a glance, and here we can immediately spot some problems. For example, we have some columns that could have zeros. For example, the number of times pregnant could be 0 if this patient was never pregnant, this woman. But for example, the plasma glucose concentration cannot be 0. This is probably something, or the blood pressure and so on. So probably 0 is being used for missing values. This is something that sometimes happens. When Pandas has missing values, it puts there not a number, but maybe the table that you're reading has some different convention, and so you could have, instead of just having an empty entry in the CSV file, you could have some other value. So in this case, we need to do something about the zeros, and we can do this. We can, let's assume that in diabetic can be 0 or 1, because this is the two, these are the two classes. Age does not have a problem, because if we look, I'm not showing here, but if we look at the description there, age is never 0, so we have this value for all the subjects. But then and the number of times pregnant could be 0, that could be correct, but these other columns must not be 0. So what we can do is we're going to fill in our data, so all the values for all the rows and just these columns, we're going to fill with the values obtained by replacing those with replacing all the zeros with not a number. So this is one easy way where we can mark all these missing values as actually missing values and not as not a number. The difference this makes is that when you're computing statistics or you're plotting your values and so on, if it's a 0, it counts as a 0. If it's not a number, then Pandas will ignore it because the value is missing, so it will not count for the sums, the maximum, the means, and so forth. So now that we solved that, we can see that we no longer have a minimum of 0 in these columns here, and we updated the mean, the standard deviation, and all of those. So to sum up, these were just a few examples of how we can use Pandas to load tables, access the tables by the index, by the names of the columns, and then do some manipulations like selecting the data that we want, fixing problems with the data, correcting the format, marking missing values, and so on. So this is just to give you an idea of what you can do. If you are working with, for example, Excel files that contain where you have in each file or in each spreadsheet you have a single table, or if you are dealing with the tables of data in CSV or from the internet or something like that, then Pandas is very useful because it wraps lots of functionalities for working with the data. This is just a starting point for you to have an idea of what you can do. If you're actually working with this, then my advice is to check the documentation. In the books I recommend, you also have examples about Pandas, but it's very easy just to Google particular examples and see the recipes. Okay, so let's take a short break, and we'll continue at 5:45. So 5:45 with the second part, where I'm going to show how we can use the Pandas for visualizing data too. Okay. See you soon.